我想说抱歉，我并不能用中文去 present 我今天的 topic。So 如果你们等下有什么问题的话，你们可以用中文发问，但是我的 presentation 我会用中文讲解。Okay, so we start with our topics today. So this is so today I would like to present portable technology for pharmaceutical and applied market. Okay, so for today's agenda, I will cover different topics about the raw material identifications and the handheld solution, Raman technology overview, and today I will focus on the handheld Raman. This is our new launch handheld Raman we call the TruScan G3. I will go through the features and also the workflow and how to develop the method and do the validations, running the samples, define the result with our p-value algorithm, and also I will go through our current model for our handheld instrument. We call the TruScan RM and TruTools with the chemometric model, and I will go through some regulations compliance as well. Okay, so why raw material identification is required? So why suddenly handheld instrument become popular in pharmaceuticals or in some on-site industry? This is because of the regulations. Every pharmaceutical company actually they're required to perform the raw material identifications as part of the QC test. So how the handheld instrument can help is once they receive the raw material from the supplier, when they reach the warehouse, they need to check every drum of the raw material they receive is correct. So not just randomly select to perform the QC test to check the raw material, but they need to check every drum. We have three different technologies for the portable solutions. So first, and also I will highlight on the TruScan, this is the handheld Raman. Handheld Raman is good for the active pharma ingredient identifications, for protein products, cell culture media, and also with the chemometric software, it can perform the quantitative analysis. And we have a portable NIR, we call the microphaser RX. This is suitable for the excipient, for the cellulose, and also to quantify the moisture contained. So this is portable NIR technology. And we have another model we call the Ionic X. So this Ionic X is mainly to identify the ionic salt like sodium chloride, potassium chloride, which NIR and Raman also cannot do. Then Ionic X is a good solution for the ionic salt. And now today I will focus on TruScan. Just want to let you know, actually our TruScan is start to launch in 2007. We call the TruScan Classic. This is our first generation. And then we do a lot of improvement in the firmware, hardware. Then we launch another model we call the TruScan RM in 2013. And now this year we launched the third generation we call the TruScan G3. And currently we have sold more than 3,000 units in global. The instrument is very small, okay? So this is how the instrument looks like. It's very small. So just about 1 kg, you can bring along this instrument any way you want to perform for the raw material identifications. Not only put one side in your lab, but you can carry this instrument anyway. The instrument itself looks very small, but actually is able to provide a very fast, accurate analysis. With the small instrument, but it's able to provide a big applications for raw material identification through the primary packaging, means like you can identify your raw material through the packaging without open the packaging and do sample prep. So for handheld instrument, no sample preparation is needed. And also handheld instrument can perform the verifications of the drug substance and also for the drug products include the cell culture media. With the small system, we have a built-in selectivity test. It's able to provide a very fast method validation because in pharmaceutical company, every method they develop, they need to perform the validation. They must go through the validation process before the method can be released and run in either in the QC or in any processing. And with the system, because we design for pharmaceutical company, then the handheld Raman, the TruScan is fully compliant to regulations, compliant to CGMP and also 21 CFR Part 11. This is the workflow, okay, for the traditional workflow to perform the raw material identifications. So it starts off once the warehouse personnel, they receive the raw material from the supplier, they will upload the materials, then log to the system, check the spec, do the sampling, then once the sampling, they will send to the QA/QC for the analysis. Then once they receive, they will have to log to the system again, assign someone to perform the analysis. So it will be depends on your raw material. It can go for wet chemistry or FTIR test. So once the test is done, then you will log to the system and get the approval from the second reviewer. And all okay, result approved, then release from quality to the production. So this is the traditional workflow. With the handheld instrument, we can skip certain steps. We can skip this step to cut down the time and also to cut down the cost. We're able to use the handheld instrument when you receive the raw material and then you check the spec. Okay, now I want to verify the raw materials, whether what I received is correct. Because sometimes the label is acetaminophen, but when I check the raw material, actually they're sending the raw material. Why the result is failed? This is the ibuprofen, so actually they're sending the raw materials. With the handheld instrument, you can fasten the process and reduce the analysis time. TruScan RF is based on the Raman spectroscopy. I just go through a very brief introduction about Raman spectroscopy. In Raman spectroscopy, we're using single wavelength laser light. We're using 785 nanometer. So this laser will shine on the samples, and then it will generate a Raman scattering light with a very low energy. The Raman scattering light will reflect back to your detector, and it will generate a very unique spectra for each compound. So every compound, every materials, they have their unique spectra. So this spectra, you can use it for the qualitative analysis, means you just want to perform the identifications to see whether this is the right materials, or you can use this spectra for quantitative analysis. You want to know about the concentration, you want to know about the assay of your raw material. So this spectra you can use for qualitative or quantitative. And because we have a different techniques, so actually TruScan RM cannot do everything, cannot do 100% of the raw material in your warehouse. That's why they come with the different technology like I shared before. We have an NIR technology, we have an XRF, and also we have a Raman technologies. So actually these three techniques is like a complementary. Anything, some material will be more suitable with NIR, like for example like grains, natural products like light sensitive materials, fluorescent samples is more suitable with NIR. Like ionic salt will be more suitable in XRF, or some sample like very light colors, solid, gel paste, either Raman and NIR is suitable. With the Raman, we can analyze a polyatomic ionic salt, non-polar materials, and also for the liquid samples, because for NIR you will get a moisture peak, you can get a water peak. Sometimes it will interfere your overall spectra. Then liquid samples is more suitable with the Raman, because Raman is almost transparent to the water peak. Okay, so almost 85% of the raw material suitable to analyze with the Raman techniques. So what material is included is like just now I mentioned, so like active pharma ingredient, like organic solvents, sugar, starch, polymers, inorganic polyatomic salt as well. So this is suitable to analyze with Raman. And some materials like very black color, very dark color samples, which will cause the heating and also fluorescence effect. These samples is not suitable with the Raman techniques. Then you have to go through with other methods which is more suitable. And then for the FTIR, NIR, or even Raman, unable to analyze like metals, alloys, or very diluted samples, and also include the ionic salt, like just as I mentioned. So if you want to analyze the ionic salt like sodium chloride, potassium chloride, then you have to go for the XRF technologies. Okay, so I will go through the TruScan G3. So for today's focus, we will go for the handheld Raman. So TruScan G3 we just launched last month. And there is a lot of new features coming out from the G3 compared with our current TruScan RM. This is the point that this is the way of the laser aperture that you will point to your samples to acquire the spectrum. And it can be attached with different types of accessory. And we have a hot swap battery, which you can change your battery without interrupt your operation. Means, suddenly you found your instrument out of it. Almost left 10%. I have to change another battery. So in most of the cases, you have to power off the system, then change the battery. But now, with the hot swap battery, you can just take out the battery without power off the system and change another battery, continue your analysis. This system has an improvement on the keypad as well. Now the system comes with the touchscreen. Our previous version only have a keypad function. Now we have a touchscreen because a lot of customers is asking for touchscreen. Everything must come with the touchscreen. So this touchscreen can adapt for the nitrile or the thick glove. So when you wear the glove, you also can use the touchscreen. And now there is 3 different parts for the laser indicator to show to the customers, okay, now your instrument is running. So you have to be careful, because although laser light is like not very harmful, but you must be careful of your for the laser light. So there is a 3 indicator, and there is dedicated laser arm to turn on your laser power as well. So this is some of the new features in our TruScan G3. And for the accessory wise, our instrument can attach with different types of accessory. So this accessory depends on what packaging material you use. Like nose cone, you can point directly to the plastic bag and to get your Raman spectra. This nose cone. So later during the hands-on session, I will share with you how this nose cone, how the vial holder looks like. So we have a vial holder to hold the samples, which is kept in the vial. And then we have the tablet holder for the finished product. And we have an additional new accessory. This is our probe. You can immerse directly into your packaging material. It can be powder, it can be liquid to get the spectra directly. And with the nose cone, we can point directly to our primary packaging like the plastic bag. The plastic bag can be 1 layer, 2 layers, 5 layers. So you can point directly to your packaging materials. And we have a fixed distance 18 mm to the focal plane. And with this fixed distance, constant distance, we're able to create a very robust method, very accurate method, and you can easily transfer the method from one instrument to another instrument. So it can point directly to your vial, to your plastic bag to acquire the spectra. And this is the hot swap battery that just I mentioned. This is a very good feature. So you can take out the battery without power off the system and change another battery. So this is without turn off your system and interrupt your operations. For the connectivity wise, we have different types of the connector to adapt for different customers. So some customers, they will still prefer to use the Ethernet. We have the Ethernet dongle, and then we have a USB-C type. And now we come with the Wi-Fi, then you put in the Wi-Fi dongle. This is optional for our customer to connect to the Wi-Fi to transfer the data without using any cables connections. And this is I want to highlight for the customer who currently is a TruScan RM user. So if they are currently is a TruScan RM user, they want to change the TruScan G3. The method is easily can be transferred from from RM to G3. You just download your method. So you just like a copy and paste, copy the method from the RM and then paste to the G3. So the method transfer is very easy and fast. You only need to perform a very minimum validations when you transfer your method. Okay, so this is a workflow for the TruScan G3. So just want to share with you how's the instrument work. This is the interface. In TruScan G3 or TruScan RM, we do not have any software. No software for the instrument. We have interface. So just to connect the instrument with our interface for the data transfer, to set up the method, to create the user for the configurations. So without the software, actually you can save your time to validate your software. So this is just the interface. So first, you have to configure your interface, we call the web UI, configure to the instrument first. Then now we need to create the method. So we have to acquire the signature. Actually, signature here is referred to the reference spectra from your reference material, from your retained samples to do the identification. So we call, in our TruScan, we call signatures. So first you have to acquire the signature, and then once you have your reference spectra add into your method, then you can continue validate your method first. So once the method is validated, yes, now the instrument is ready to use. So when you want to start to perform the analysis, so first thing we have to do the self-test. Later during the hands-on session, I will share with you how fast to perform a self-test. Self-test actually is used to verify your instrument performance. Of course, before you want to start your instrument, you have to make sure your instrument is in good conditions. Then we will perform a simple self-test with the polystyrene rod, and it only takes seconds, and show the result or pass. Okay, once the result pass, you can start to select the method, what you want to verify. And the result will show, either is matched, is passed, then not matched, it will show fail. Then after that, your result will transfer to the system. It will transfer to your archive locations. So this is the workflow to build the method for the when you want to use for the verifications in your instrument. So later I will share with you. It looks like a lot of steps, but actually it's very simple. Okay, now to develop a method or how to build a method. For the TruScan, because this instrument is applied to pharma customer. We cannot use the factory library for the verifications. The user have to create their own library or create their own method for the verification because of the audit purpose. And also to show the traceability, who is the one who performed the test, what lot number you use to create the reference spectra. So this information, everything must be traceable. That's why you have to create your own method, or we say create your own library. So first you have to get your reference spectra first. Then you just in the home page, you click on the acquired signature. Is that from my mic? Okay, then you acquire the signature. The instrument will automatically scan your samples and get the spectra. Because we only need to get one spectra for the identifications. We set a higher SNR for the system to get a very good quality spectra. So what is the SNR? So SNR is referred to the signal to noise ratio. We will set a higher target for SNR when we acquire the signature. Then the instrument, everything is automatic. Then you will end with, once they finish acquired the spectra and achieve the target of the SNR, then you stop. You will see the spectra from your instrument, then you will save this signature in your system. So later I will share with you this, the whole step, how do I perform the test to acquire the signatures. Once your method has been developed, okay, now to develop a method is very easy. You already acquired the signature, develop the method. So once the method has been developed, then you have to go through the validation process. This validation, actually we have the SOP. So every customer from pharma, they have their own SOP to validate the method. But I just go through a simple way. So first they have to collect the reference spectra from different types of packaging material. It can be from the vial, plastic bag, amber bottles. So they will collect different spectra from different packaging materials. So once they get a spectra, they will add into the method and they can start to validate the method. So during the validation, they will get another samples to test the robustness of the method. Oh, I get the different batch, then I test with this method whether I can get the pass result or not. If you get failed, that means something wrong with your method. Then you have to recheck again, retest again. After that, if you get the pass result, then you will go through for the selectivity test and also a positive test, negative test from your validation process. And here I would like to highlight what is the selectivity test. In our TruScan, we have an automatic run selectivity test. Selectivity test actually is used to validate your new build method. Then whether your method is actually able to differentiate from the list of all your materials and also compare with the factory library. If they found any similarity, that means there is a risk of your method will get a false positive result. So selectivity test actually is part of the important test when you perform the validations. So if this instrument has an automatic selectivity test, you don't need to go through a very complicated procedure. So you just select selectivity test, and then the instrument will automatically evaluate. Oh, okay, now I go for the selectivity test. The result show good. If the result show good means your method there is no similarities with all your method from your system, include the factory library and also your own created library. So means there is no similarity. It's good method. So no risk of false positive. But when you get a yellow color means warning. You have to investigate. Some of your method include in the factory library or maybe in your user created library, there is a similarity. Oh, then you must be careful. I have to check, investigate. If you get a red color means, if you get a red color, you have to be very careful. That means there is some of your method actually is almost similar with your method created. So in this case, you will always get a false positive result. That means you will get a false result. The instrument will give you the information, either your method is good, need to investigate, or risk assessment is needed. That means there is a lot of similarities in your method. Okay, yeah. So that part is more on how do we develop the method, validate the method. So once the method has been validated, then you start to use the instrument to perform the analysis. So first you have to go through the self-test, like just I mentioned. This is a very simple test. You use a polystyrene rod to perform, so it only takes seconds to complete. And it will show, oh, okay, your result is passed, or the result is failed. If you found your result is failed, then you must be very careful. Is that your instrument got any issue? Is that your instrument got any issue? Then you have to check. And our instrument do not require any calibrations. We only need annual verifications, not calibrations. We do not need any adjustment on the instrument. We only need to verify the instrument performance. Then you will be able to get the result from the peak. Okay, so from the self-test report, you were able to see the peak measured from the polystyrene, and then you will compare whether your result is pass or fail. So there is an overall overall result for the polystyrene peak positions analysis. Okay, so once your self-test is done, okay, now we can start to run a method. From the home page, you select Run Method, and then the instrument will come out a message to ask you, okay, now you can turn on your laser. Then you will press to turn on your laser, and you can select what compounds you want to analyze, batch number, sample ID, and also the optional accessory. So accessory, you can select what accessory you are using now to get the spectra, to get the result. This is just the information for the traceability, just in case you get failed result. Then you check it, is it I used the wrong accessory or not suitable accessory? Then you can investigate through your accessory. This is another additional information. Then it will start to run, and then it will show the result, pass or fail. And p-value, this p-value actually is to define your result, pass or fail. Okay, how it defined? This p-value is, if your p-value is above 0.05, means your result is pass. If your p-value shows less than 0.05, means it's fail. Okay, so later I will explain more details. What is the p-value algorithm? How the instrument define this material is the same materials or different materials. Okay, yeah. Then how the instrument define the result? First, you already have your method with your built-in define reference spectra. Then you will acquire a spectra from the samples, and the instrument will compare these two spectra. If the instrument calculate automatically, and it found that these two materials are matched, then it will show pass. If the instrument show fail, means these two materials are different. So this is how the instrument define the result pass or fail based on your reference spectra compared with your sample. And we have one one new features, which is we call the discovery scan. This is an investigation option. Okay, this function is like, okay, if you have something is unknown, for example, or I get one bag of raw material on the table is a yellow powder, or I get a liquid from the table but no label. I have no idea what sample is this, what liquid is this. But in pharma, right, you cannot just leave it, oh, okay, just leave it or discard, because maybe this is something is poison or something, you want to use it or maybe for the formulation. So you have to check, what is this material? Now you can use this discovery scan function, scan your samples, and then once you scan your samples, you will get a spectra. This spectra, the instrument will check through all the whole list from your factory library, check from your user created library, and then it will come out, okay, match with what materials. So, it shows that it matched with A1887, and the p-value is more than 0.05, is 0.4691. Means this material have a good match with this. So later I will share with you. I will also do this test to show you how this investigation option is working. And this is the interface, like just now I mentioned to you, this is the TruScan G3 interface we call the web UI. This interface is able for you to create the method, check your signatures, create your username, and then also the product information, like what product is it, what serial number, and how's the battery state, what is the battery status now. So this is all the information you will able to get from the web UI. This one I will also share with you during the hands-on session. And for the p-value, this is a very important parameters, because this p-value will define your result is pass or fail. The default p-value for TruScan is 0.05. That's like I keep mentioning, above pass, below than 0.05 means is fail. So this p-value is our default value, but you can edit. Like I want to increase the p-value, I want to make it more straight. I put 0.2, 0.3, yes, you can edit the p-value. Okay. Just now I keep mentioning about p-value, but actually what is the p-value? P-value, P is referred to the probability value. So this is a patented approach to establish the material identity with the statistical confidence. And with the p-value, it offers a superior selectivity and specificity compared with other handheld instruments. And the p-value approach makes the identification, method creation, and validation is extremely super easy. Later I will share with you. Okay, this is a very long explanation about the p-value. Okay, so I put it in a more simple way. So in the market, most of the handheld instruments they use HQI, we call heat quality index, or the correlation coefficient to define the result. So they actually, with this HQI and CC, they measure the similarity. They will compare the reference spectra with the sample and they check how similar of these two spectra. Oh, if your range you set 90%, so if you get more than 90% means it's pass. This is how the HQI and CC work. So they will compare the similarity, how similar of these two spectra. But p-value is different. Our patented p-value, we are measure the differences. So we are measure what is the difference between your sample spectra and also with your reference spectra. We are not measure the similarity. They will compare, okay, the instrument is very smart. They will compare, oh, okay, they will compare the peak intensity, they will compare the peak position, and they will check is there any additional peak come from your sample spectra. This additional peak, is that because of batch-to-batch variations, maybe is missend of the raw material is different, or maybe it's because of the packaging. Then the instrument will put this factor into the p-value calculation, and then the instrument will define, oh, these differences, is that very significant or actually just the minor differences, and the instrument will define these two materials are same or different. So this is how the p-value works. This is a description of how the p-value. So we are sensitive to differences. We are not measure the similarity. So I want to highlight is we are measure differences. Okay, put in very simple example. Now we have two spectra. One is from your library. Your library is the butyl alkylate reference. And then I scan one sample. This is a red color, is my test samples. What I see from here, these two spectra looks very similar. But when I overlap these two spectra, I found that there is some of the region actually is different. This is not the same when I put in the overlap version. So we actually found that these two materials are different. These two materials are not the same. The standard is the butyl acrylate. Actually, the sample is hydroxypropyl acrylate. It's totally different materials. So with these differences, we are able to differentiate these two materials. And now we're using the different algorithm to calculate. One with the p-value, you can see our p-value is close to 0. Means it's below than 0.05, means it's fail. But if we use these two spectra and calculate in the HQI, pass. Now 0.98 actually is almost 98% match. If 98% match, I will assume these two materials are same. But these two materials are different. Why? In TruScan G3, actually we run real time. What is the meanings of real time? We actually keep track of the uncertainty. We put the factors, the external factor, into the considerations, like maybe the variations from the instrument, from the environment, from the materials. They will put in all these considerations to get a Raman spectra. We measure the uncertainty from time to time when you perform your analysis. That's why we call real time. With this function, we're able to create a very robust method. And then it's very easy to transfer from instrument to instrument. And you no need to scan. Some instrument, maybe you need like one sample, I scan 5 times to get the repeatability. This instrument, you only need to scan 1 time for one sample and add into your method. Of course, if you have maybe, I have a different supplier, I have a different layer of packaging, different types of packaging material, maybe sometimes I use amber glass. You can put all this spectra with different packaging into the same method to make your method very robust. No matter what you scan through the packaging, you scan through the you will get a pass result. but not multiple scan. What I mean multiple scan is one sample scan 10 times to get the average. No, this is not the way. I put another example. So these 5 compounds have a very similar structure. With the p-value, I can easily differentiate phenol from other compounds like benzaldehyde, toluene, benzyl alcohol, or benzoic acid. With the HQI, you will get a very good match. Means HQI unable to differentiate phenol from other compounds. We are able to achieve a reliable specificity. That means our p-value has a very high specificity and selectivity among all the close related materials that compared with other handheld instruments that fail to differentiate it. So we are easily to differentiate from p-value to other compounds. I put in our daily product, okay? If we use the HQI, okay, now I want to buy a butter. I use the HQI to differentiate. We can differentiate these 5 different types of butter as a butter. Just a common, all butter, but I cannot differentiate what butter is this. Butter, this is butter, but actually this is a peanut butter. With our TruScan p-value, we are easily to differentiate, this is butter, this is a peanut butter. So it can be differentiate each type of butter instead of put it all together as a butter. So means our p-value has a very high selectivity to differentiate the similar materials. So I put in our daily product. Okay, so just now is all about the TruScan G3. Now I would like to take some time to share with you on the TruScan RM and also the TruTools. So what is the TruTools? So this is our another model we call the TruScan RM. But this TruScan RM very powerful. It's able to add the chemometric software we call the TruTools to have an additional function to perform the additional qualitative and quantitative analysis. For normal handheld, you only can perform the qualitative, or I just want to know this is the same materials or different materials. But with the TruTools, with this chemometric software, we are able to perform quantitative analysis. Now we can quantify, how many percent of this raw materials, how pure is this material, and also we can discriminate some material which is very similar, like for example calcium stearate, zinc stearate, magnesium stearate, and we can expand the TruScan RM applications not only for the chemistry product, but it also can use for the biologic products as well, like cell culture, for the purifications to quantify the samples to as an optional for HPLC or GC, and also biologic product we can test the post-shipment ID and also do some quantification for the formulated drug product. The TruTools plus TruScan RM we can use for the counterfeit product as well to check if this product is original or not. So we can use for the finished product testing. This is a workflow with the TruTools. So if the TruScan RM have a TruTools, it can be customized the acquisition parameter like the laser power, the acquisition time, and also how many spectra you want to average. So this is additional features in the TruTools. Then once you optimize your parameter, then you can send your data into the chemometric software, we call the item vector software. Then we do some processing, build the model, then import back into the system for the qualitative or quantitative analysis. And we have a different types of model. With the chemometric, you can build different model. If you want to perform the quantitative, you can use the PLS model, the partially squared. So it can support up to quantitative, up to 10 chemicals. And we also have others. You can build your models for qualitative. We have a PCA models. We can create a PLS SQ. So PCA is only like a pass or fail. PSS SQ, you can put in the quantitative limit to make it more complicated, not complicated, it's more better function. And then for the PLSDA, this is for the qualitative. And you can put a group of samples which is very similar, then you can easily to differentiate. So later I will share with you some of the examples. One of our application notes, we actually do the study about the opadrate. This opadrate actually is film coating. If you take some medicine, right, you see the tablet come with the different color, pink, white, yellow, so to differentiate each drugs. So this opadrate actually is a coating, it's a film coating, but it comes in the different colors like blue, pink, purple, white, yellow, more than that. So how do we define this opadrate in different colors? Although it's in different colors, but actually the spectra, it looks very similar. A lot of users actually they have a problem to differentiate this opadrate with different colors because of the spectra is very similar. But with the TruScan, with the TruTools, we can optimize the parameter on the laser power, exposure time, and also the average spectra. Okay, how do I define? I can use the chemometric software to differentiate these 5 groups of opadrate. Okay, I get the raw data, put into the item vector software, then I can study, oh, these 5 groups actually can separate to each other, can separate well. No overlapping in between group to group. So it able to differentiate means if I can create this group, right, when I put into my TruScan RM means I can easily differentiate this opadrate blue with other group of opadrate. So this is how we use the chemometric software to check the differentiation. And another example is the magnesium, calcium, zinc, stearate. So this is also very similar structure. And we put in the chemometric software, we also see that these 3 groups can be separated easily. No overlapping. So although zinc stearate is very broad, but no overlapping with calcium stearate or magnesium stearate means it's able to differentiate well. And another example is also very common raw material in pharma. The povidone and cross-povidone looks very similar. And we put in the chemometric software to build the model. We found these 2 groups also can be separated well, no overlapping to each other. And also it can use to identify 14 different types of monoclonal antibody. So this is for the biologic samples, and it also can differentiate some of the monoclonal antibody. The TruTools also can use to study the variations. They can study from the models any changes from the media to media. So like for example, this media B and D, from time to time, actually they separate out, but suddenly they combine together. So we can study about, oh, this media B or media D, actually they have a degradations. So we can study the degradation. First is like this. After that, they will have changes on the media. And TruTools can use for the quantitative. So of course, at the beginning, you have to collect the spectra with the different concentrations, and then you can build the PLS model, check the linearity. Oh, I can get a very good linearity 0.997, and then I can use this PLS model, import into the TruTools, and we can do the quantifications. Not only qualifications, but can do the quantifications. Same with this, we can collect the spectra with different concentration, put into the chemometric model, build the PLS model. we check the linearity. Once it's validated, then we can start to quantify the sugar concentrations. So with the TruTools, you can do additional processing on the qualitative, and also it can perform quantitative. So this is the power of the TruTools. And the last slide, I would like to highlight the compliance. We are compliant to 21 CFR Part 11, and we also comply to the Pharmaceutical Inspection Cooperation Scheme. This is a PICS, so we are compliant to PICS as well. And also in the pharmacopoeia, Raman spectroscopy comply to USP, we comply to EP, and this instrument is suitable for pharmaceutical company. Okay, that is the last for the summary. So the pharma company is looking for the handheld instrument to identify the incoming raw material in QC to get quality therapies to the market faster. So as a conclusion, with the handheld instrument, you're able to perform a very fast, accurate, and also there is no, this method is not destructive method. So it's very easy to carry from one area to another area. Okay, thank you.